Hey, mind if I join you?
Not at all. Actually, I could use some help with this puzzle.
Oh, is that Sudoku? I love these. What's the trouble?
I can't seem to figure out where to place the last numbers. Everything else is filled except for these zeros.
What? That's the thing. There are no zeros in Sudoku. Every digit from 1 to 9 has its place, but zero is like the unsung hero of mathematics. We never use it here, but it's everywhere else.
It's just a placeholder, isn't it?
That's what most think, but it's so much more. Zero is a powerhouse, a fundamental concept. Without it, modern math wouldn't exist.
Really? I never thought of zero as anything special.
Absolutely. It's a symbol, an idea, and a complete game changer in history. Did you know it has a story that goes back over 1,000 years? It has roots all over the world.
No way. Tell me more.
Well, it all started in ancient civilizations.
Join us on a journey through time to discover how zero became the symbol we all know and love.
When we dive into the history of zero, it's a fascinating journey through various cultures and epochs. Zero, as a numerical placeholder, has its roots in different parts of the world.
In ancient Mesopotamia, around 2000 BCE, the Sumerians used cuneiform writing on clay tablets to represent numbers. They ingeniously employed a symbol to denote nothing or an empty space. This symbol acted as a placeholder in their number system.
Moving on to ancient India, specifically during the Gupta Empire, around the 5th century CE, Indian mathematicians made pivotal contributions to the evolution of zero. They introduced the numeral zero and integrated it into arithmetic. This step was a significant milestone in the development of zero as a number.
During the Islamic Golden Age, which spanned from the 8th to the 13th centuries, Arab scholars played a pivotal role in the advancement of mathematics. One notable figure was Al-Khwarizmi, the Persian mathematician who transmitted Indian numerals, including zero, to the Western world. They also refined the use of zero as a placeholder in positional notation systems.
I see now. Zero laid the foundation for the decimal system, the very basis of our contemporary numerical notation as both a numeral and a placeholder.
So that's just some information on how zero came to be historically.
Are you two seriously still going on about the number zero? It's literally nothing.
Look, this is a picture of the first ever symbol of zero.
You mean to tell me that this is the first ever symbol for zero?
Okay, so it's an old circle, a placeholder for nothing. It's not a big deal.
No way you don't see the power that zero has. Let's learn about zero as a placeholder. Zero is often used as a placeholder in various numerical systems, including our decimal system, to represent the absence of a quantity or the absence of a value in a particular position within a number. The concept of using zero as a placeholder is fundamental to the way we represent numbers and perform mathematical operations.
In the decimal system, that is commonly used in everyday mathematics, zero serves to indicate that there are no units, tens, hundreds, etc. in a particular position. For example, in the number 207, the zero in the tens place indicates that there are no tens and only 7 units are present. Without zero as a placeholder, it would be difficult to distinguish between numbers like 207 and 27.
The use of zero as a placeholder is not limited to the decimal system. It's a general concept in positional numeral systems, where the value of a digit depends on its position within the number. Other numeral systems, such as binary, octal, and hexadecimal, also rely on the use of zero as a placeholder to represent values in their respective positions.
Wow, so zero is everywhere, shaping our world in ways we probably don't even realize.
Exactly. That's just scratching the surface. There's a whole world of zero to explore and how it's used.
I guess it doesn't have a certain power to it. Alright, I'm curious. What else should I know about zero? It seems like a simple number.
I guess I'll admit that zero may seem like a simple number, but its significance reaches far and wide. I can already think of a few places we use zero even when we don't realize it. Maybe that'll prove to you how important this little symbol is.
Oh, brother.
In the realm of mathematics, zero plays a pivotal role. It acts as a placeholder in our number system, enabling us to represent numbers beyond single digits. For instance, in the number 205, the zero in the tens place tells us there are no tens.
In the realm of physics, Zero serves as a reference point, especially in temperature scales like Celsius and Kelvin. Absolute zero, denoted as 0 Kelvin, represents the lowest possible temperature where particles have minimal thermal motion. In the world of music, zero is essential for musical notation. A zero in sheet music represents a rest, a pause in music indicating silence for a specific duration.
Its role is pervasive and indispensable. From music to math, it shapes our understanding of, well, everything.
So how did the zero even come to be? Who started it?
Fun fact, it wasn't just one person. So many people thought of the idea of zero without ever meeting each other and helped develop their ideas into the zero we know and love today. When it first arose, zero began its spread worldwide, becoming a testament to the interconnectedness of human civilizations and the enduring impact of mathematical ideas on our understanding of the world.
In India, zero was initially represented as a dot or a small circle. This innovation is attributed to Indian mathematicians and scholars around the 5th century CE. The use of zero was crucial in the development of the decimal number system, allowing for more efficient and accurate calculations.
Eventually, the concept of zero found its way into the Arab world, where scholars further developed and disseminated the concept of zero.
The term zero itself comes from the Arabic word sphere, which means empty or zero. This word was used to represent the Indian numerical concept of zero, and it later evolved into the English word zero, also contributing to the idea of the zero we know today.
China and East Asia were introduced to the concept of zero via the Silk Road and via cultural interactions that marked a significant moment in the history of mathematics and beyond.
Chinese mathematicians and scholars began to assimilate Indian numerical concepts and symbols into their mathematical notations and calculations. Now, they were able to perform more complex calculations and make record keeping and commerce more accessible.
Then came the age of exploration and globalization. From this, the concept of zero spread and grew an exponential amount far beyond their places of origin. Even more so, European colonial powers established trading outposts and colonies across Asia, Africa, and the Americas, allowing for the exchanging of mathematical and scientific ideas.
Whoa. I understand this in its entirety so far, but what about when you have to do the unthinkable?
No.
You don't mean?
Yes, when we have to divide by zero.
No! You're right. That's a big and confusing problem. When dividing a number by zero, no solution can be applied without causing mathematical paradoxes. This challenge arises because division is essentially a way of determining how many times one number fits into another. This inconsistency can lead to a breakdown in mathematical logic, causing confusion and errors in both theoretical and practical contexts.
Division by zero can lead to the undefined results, making it essential for mathematicians and scientists to carefully consider the limits and conditions under which division operations are performed.
I see. So it just underscores the need for caution and precision when working with mathematical expressions and the importance of understanding the limitations of mathematical operation. Sounds good. I know now that we can never divide by zero.
Hold your horses. We still have to consider indeterminate forms, like 0 over 0. These can arise when dealing with limit calculations. This means that we're not looking at the problem as a simple division, but rather as a question of what the expression approaches as the numbers get smaller and smaller.
So you're saying it's not just about the numbers?
Exactly. In mathematics, particularly calculus, when we talk about limits involving 0 over 0, we're interested in the behavior of functions as they close to a certain point, not necessarily at that point.
That's where the magic of limits comes in. Limits help us solve the unsolvable. By finding a pattern to the values around that point, we can sometimes figure out, well, I'm getting way ahead of myself. We're learning about the history of zero, not about what a limit is.
I understand. So while you can never just divide by zero in regards to limits, you're kind of taking a sneak peek at what's around the corner without actually turning it.
That's a great way to put it. It's like knowing the end of a story without reading the last page.
So next time you see a zero divided by zero in calculus, think limits, not division.
So there you have it. The history of zero is a remarkable journey that highlights the evolution of human understanding and mathematical innovation.
It's a testament to the development of the way we understand and interact with the world through numbers. Zero, once a revolutionary concept, has become an integral part of our daily lives, underpinning our understanding of mathematics, science, and beyond.